So here's another implicit function, or y is an implicit function of x in here, and I think it's impossible to solve for y in this case. So we are going to use the differential operator, which preserves equality. That's just saying that if we took the derivative of both sides of this equation, we'd still have an equality. So what's the derivative with respect to x of y? Well, that's just y prime. And what's the derivative with respect to x of the right-hand side? That's 2. And now we have to take the derivative of sine of something. Well, the derivative of sine of something is equal to cosine of that something, pi x minus y. But then we still have to take the derivative of that something, pi x minus y, derivative. And this is the place where some people might make the mistake, is right here in this step, taking that derivative. But, so let me rewrite this. Y prime is equal to 2 cosine pi x minus y. And here I go. I'm going to take the derivative with respect to x of pi times x minus y. Now pi is just a constant. It's 3.1415926 something something. So when we take the derivative with respect to x of pi times x, we just get pi. And now we have to subtract. Now what's the derivative of y? Well, that's just y prime. Okay, so now where's our laser focus? Our laser focus is right here on this y prime and this y prime. However, where we're going to take care is that this term right here is being distributed over both of these terms. So what do we have? We have y prime is equal to 2 cosine pi x minus y, okay, times pi, okay, and now I'm just going to write this y prime first, but minus y prime times 2 cosine pi x minus y times 2 cosine pi x minus y. I've been a little forward looking here because by reordering these terms and putting the y prime first. So adding this term to both sides, remember our laser focus is right there and right there. We're going to strip away everything we can in order to isolate that. So if we add this term right here to both sides, we are going to have y prime plus y prime times 2, well, I'll leave it here, 2 cosine pi x minus y is equal to, well, the only thing left on the right hand side is this term right there, and I'm just going to rearrange terms to make it a little more easy to see. 2 pi cosine pi x minus y. Factoring out a y prime from the left hand side, we have y prime times 1 plus 2 cosine pi x minus y, and that is equal to 2 pi, here come the endorphins, 2 pi cosine pi x minus y, here they come, get ready for them, divide both sides by this term, 1 plus 2 cosine pi x minus y, and we have our y prime, 1 plus 2 cosine pi x minus y. Oh, I was just super crazy careful. So this is our y prime. So that was just algebra. Oh, and this term right here is a 1. Okay, so we want to find y prime at 1, 0, and just a quick nod to my to my boss. If we had gone right to this step right here, use blue. If we at this step right here, we could have put in the point 1, 0. And we'd see that it would have been really easy to solve for y prime, or much easier to solve for y prime. But I really wanted to find y prime. I haven't done calculus in a long time, and this is more for me than it is for you. Okay, so evaluating at 1, 0, let's just look across some of these terms. And you can even do this if you're careful. Instead of, it's just for speed, right? Remember, y is equal to 0. So this term, boom, 0. This term, boom, 0. X is just 1. So we're really finding the cosine of pi times 1 cosine of pi. So you could even do this. You could put a 1 right on top of the x and a 1 right on top of this x. Now you can see that y prime evaluated at the point 1 comma 0 is equal to, we have 2 pi cosine pi. Well, cosine of pi is -1, so we have -2 pi in the numerator. And in the denominator, we have 1 plus 2 times the cosine of pi, so that's 1 plus 2 times the -1, so -2. So we have our slope is -2 pi over -1, or just 2 pi. So we have the slope, well, we have the slope of our tangent. I have to be clear when I say that. Okay, so we have our slope of our tangent. So our tangent line is equal to y minus a y on the line, which is 0, is equal to 2 pi times x minus 1. And so this is just y is equal to 2 pi x minus 2 pi. Okay, that's in slope intercept. And what about the normal line? Well, the normal line is the negative reciprocal. So we have -1 over 2 pi is equal to the change in y over the change in x. And you can solve this for y equals a function of x, but this is an acceptable form too. I don't know what it has in the back of the book. I don't. I guess I don't have time to look, so I guess screw that. Let's see if I can find it. This is section 3.7. Okay. 3.7 negative x over 2 pi find plus 1 over 2 pi. Okay, so they just put this out here. Equals negative x over 2 pi plus 1 over 2 pi. Okay, that's it. Hopefully that was helpful.